Can you see the screen?
Yes, sir.
Yeah. Yeah, last time we have seen this problem statement and we have given the loads. So today we will learn how to apply the two-way and one-way loads directly. We can say it is a shortcut. Last time we have calculated these loads and then applied on the beams. So this was the, I think, loads, whatever we calculated, WLX by 3, WLX by 2, and so on. So actually in Staad, we have the facility that we can apply the loads of the slabs directly in terms of kilonewton per square meter. And Staad will automatically transfer the loads as per the trapezoidal or triangular loading to the beams, or one-way loads also, half load here and there. So we will apply the load in kilonewton per square meter. That means slab load directly. For example, this is your live load, kilonewton per square meter, 2 kilonewton per square meter. Floor finish 1.5 kilonewton per square meter, and dead weight 3 kilonewton per square meter. So, and SIDL 1.5. So actually we need not to do these steps. This is a manual method, we can say. So if you want to do it manually, then this is very good method. But yes, software is giving that facility. So those who have done with the ETAP software, we generally directly apply these loads on the slabs, 3 kilonewton per square meter, 2 kilonewton per square meter. Actually, Staad is little, we can say, tedious job actually here, which I really don't like regarding the Staad, but fine. It has its own, we can say, tool. So let's open yeah, last time model. In this case, we will only learn how to apply the two-way loads. So these were the loads, whatever we have applied. We created the load cases, dead load, SIDL, live load, and combinations. And then we have applied these loads per meter after calculation of two-way and one-way loads. So in this problem, what I will do, I will delete these and let's learn how to apply two-way, one-way loads here. So let me save this first. We can edit the existing model like anything. We can edit, we can delete loads, we can delete members, we can do anything. You can change the supports. So existing model can be changed. So let me delete all the loads. I'm keeping the load cases as it is. SIDL, dead load and all. You can click the loads and delete command from the keyboard. And combination, let it be as it is because we want the same combinations. Now in dead load, what loads we apply? First is always self weight. Click on the dead load, then add. Then click on the self weight and -1. This is Y direction -1. Load factor, add, close. Then click on the self weight and say assign to view. So self weight of members will be added here. Now in dead load, what are the loads? Dead loads में क्या क्या loads है? One is the self weight of the slab, which is how much? Dead load self weight. This is 3 kilonewton per square meter. So let's say the slab thickness is 120 mm and we want to apply this load on this slab. So how to apply that load? Now let's learn that command. Click on the dead load, then add, and here click on the floor load. See here, floor load. Now you will see this window, and there are certain things given: X range, Z range, Y range, and pressure, and some coordinates are given over here. So that means, let's see, I will tell you first mechanically, and then we'll understand. So what is the pressure self weight of slab? How much is the self weight of slab? 3 kilonewton per square meter, right? This one. So let's put this 3, but it is -3 because it is a gravity direction. So -3 will be the pressure or self-weight of the slab per square meter. Now Y range, keep this Y range as it is. Now what is the Y range? Here it is asking what is the Y range, minimum and maximum. So Y range means at which location the slab is located. So you know that this is the level of slab. What is the height of this slab from the origin? This origin is 0, 0, 0. You know this 0, 0. And what is the Y ordinate of this? If you double click on this, then you will see that Y ordinate is 4.5. Okay. Now generally, we give the Y range little above and which is maximum. So it is 4.5 Y. So I can give here maximum 4.6, let's say. Minimum below that. So 4.5, let's say this is 4.1, not 4.1, 4.4. That means your slab is located between these two numbers. So you can take any number actually, but just take, I'm taking arbitrary 4.4 and 4.6. 100 mm above this and 100 mm below this. Then X range. X range means of. So you know that this is your two-way slab. Slab like this. That means this is your slab under consideration. This is your two-way slab, right? Now, actually, it is asking the location of the slab actually with respect to X range. So what is the X value of this point? X coordinate of this point? Yes,
0.
it is 0. I will tell you. If you can click, if you don't know, just click on this node. You will see that X is equal to 0 over here. X is equal to 0. So put this 0 in minimum because it is we are this locating from left to right. Now this is your second X coordinate, which is defining this slab. If you click on this, what is the X coordinate? 4. That means 0 to 4 here. So 0 to 4. Minimum 0, maximum 4. Now it is asking Z range. So you know that this is your Z range. So what is the Z coordinate of this? Double click here. Z is equal to 0 over here. So put Z is equal to 0 for minimum. And what is the coordinate of this? Z coordinate? Z is equal to 4. So 4. Okay. And then you can say add and close. Now if you click over here, this Y range loads are added here. You can see here. Correct. So are you getting hello? Are you getting this?
Yes, sir. Yes, sir.
Yes, sir.
Any doubts, question? See what I'm doing? I'm giving the Y range means the location of the slab at which height it is located from with respect to the origin 0. Okay. So that I have given, but I'm whenever I give this, I'm just giving 100 mm below that slab level and 100 mm over that slab level. Then you need to locate the X range. So this is your slab. So this ordinate X ordinate and this X ordinate. And again Z direction, this is Z ordinate. Okay, then you can define this slab. Now if you go for this slab now, let's go over here. Now, no, let it be like this. Now I want to define this slab. So can anybody tell me what is the Y ordinate for this and what is the X coordinate? So let's say add again, click on the dead load, add and floor load. Now Y range pressure is same because for one-way slab also it is -3, self-weight of the slab. Now what is the Y range for that? Same, 4.4 to 4.6. What is the X range for this? First is this point. Yes. So X range, click on double click, X is equal to 4 over here. So put X is equal to 4 here. And then second point is this in X direction. X is equal to 5. So put this is equal to 5. Now Z range for this point, Z is equal to 0. So put 0 here minimum. And what is the Z value for this? 4. Now as our slab is one way, click here one way distribution. Okay. And then say add, close. Now once you click over here, now you'll understand that loads are. Now this is one way you can see this. See the rectangular part is like this. If you see the plan, go into the plan, then you can understand this. Correct. So have you got how to put the Y range loads?
सर वाय रेंजला आपण म्हणजे असं का दिलं ते
कुठलं?
पॉइंट्स डिफाइन करताना 4.4 आणि 4.6
see, now actually you can define directly 4.5 also. Let's see this. Here you can directly define 4.5 and 4.5. See why I'm giving this. Generally what happens whenever you prepare any model, big project model, there is a possibility that you are creating mistakes in developing the nodes. Let's say this node is little below due to your error, manual error, human error we can say. Let's say it is at distance 4.4 4.45. Let's say the y ordinate of this is 4.45, so it will be missed and it will not apply any load. That's why I'm taking little below and little above. Getting?
येस म्हणजे आपण नेहमी करताना तसं प्रिकॉशन करूनच घ्यायचं का
Precaution. We are taking the precaution. See, exactly it should be 4.5, ideally speaking, because you know that it is exactly at the 4.5. But I am taking
येस
little because I'm taking giving the range, because if you have any problems in the modeling, let's say this is your upper part and this is your bottom part, whatever I told you. Let's say this is your 4.4 and this is 4.56. See, there is a possibility that your some nodes are here because you created some errors or something. There is a possibility people do error in the beginning at least, and that's why I'm just taking precaution. So I'm giving the range here actually, band. So whatever nodes are there, it will not miss that loading. Okay. So that is the only criteria. Even though you put 4.5 exactly, doesn't matter. It will still give correct because I know that currently this model is correct. But I generally suggest do this, doesn't matter. Now, so this is your dead load. Now, if you go into the SIDL, again put that load. SIDL is add Y range floor load. Now SIDL means in our case it is a floor finish, right? 1.5. Same procedure. Minus and this Y range is 4.4. Add. This is two-way load. Just verify this after clicking on this. You can verify this.
सर हॅलो
Hello.
टू वे लोड असेल तर ते क्लिक करायची आवश्यकता नाही म्हणजे वन वेच्या ठिकाणी टू वे मेन्शन करत नाही का
Yes. By default, it is two-way.
अच्छा.
I'm not clicking here. That's why it will automatically take two-way load only. If you click here, then it will show one way. I'll show you for this slab again. I know that it is two-way, but if I want to make it one way forcefully, then you can just click on the one way and then change. Then it should give actually. Why not giving? No, it is by default. It is giving that as per the aspect ratio. Okay. Now again live load, same thing. So there are some shortcuts also, but I will tell you after that once we learn that input editor. Now click on the live load. floor load, again the same thing. It is tedious, but do it in the beginning. I recommend all of you, whenever you practice as per the session actually, because I know that in the beginning the methods are tedious and time consuming, but they are basic methods and classical methods. So you should not forget that. Then you can use the shortcuts, whatever I'm telling you. Now here we missed one-way load. SIDL, how much is that? How much is this? 4 to 5 and 0 to 4. One way. Okay. And again live load, same thing. -2. Right. There is one more load, which is wall load. So you can add that wall load also. Wall load, how much is the wall load? कितना था? Brick wall, 4 kilonewton per meter. So that is in SIDL. Click SIDL, then add. Now it is a member load, which is uniform, -4. And then click this -4 and apply to these loads. You should have a beam cursor here actually. To the periphery of the building. And then add to selected beams. So that means we have applied all the loads here in this case, correct? And then you can analyze. What happened? You can take the load combination here and then it's okay. And see the results. Okay. There may be little, we can say, difference in the previous case and this case, but okay, that is acceptable. So this way we can apply the Y range loads. Okay, so is it clear to all of you?
Yes, sir.
Yes. Now let's say instead of this ground floor building, we have 2 more floors above. Okay. So see, I have applied all the column sizes, beam sizes, and loads and everything. So if I want to replicate this 2 above floors, how can I replicate this? I want ground plus 2 building. Now this is only ground building. Now I want ground plus 2 means first floor and again second floor, right? So what can we do? Select this part only, correct? All these beams and columns. Then go to the translation repeat in Y direction. What is the floor to floor height? 3 meters. And how many floors I want? 2. Now don't say link step because already columns are selected, right? So it will automatically take the columns also. It will copy the columns also. So don't say link steps. Then click OK. Now it is asking, do you want to delete all the results? Because you have already analyzed the structure. Now you are making certain changes in the analyzed structure. So you can say yes. Now here you can see you have created the building. Now you will see that the properties got replicated. So you need not to again assign the properties. You just copied it. No problem. Beta angle, if you click on the beta, it is also copied, right? Now if you go into the support is no problem. If you go into the loads, click on the loads here. Click here and then go into the dead load and go into the self weight. Now self weight is only assigned to the ground structure. That means you need to again apply the self weight. So it doesn't replicate that. So click on the self weight and then say assign to view. So this is the problem here. It doesn't copy the self weight. So you need to again apply that. Now if you click on the Y range here, now you will see that Y range load is only at this floor, which is let's say first floor. That means Y range loads are not copied. Why it is so? Can anybody tell me why the Y range loads are not copied above?
Y range is defined between 4.5,
Yes.
4.4
Yes.
and 4.
Correct. Correct. So that means we need to change this Y range only. So double click on this. Now minimum 4.4 because I'm taking just little below. Now here you can take what is the Y ordinate for this? Double click on this. Y ordinate is 10.5. So you can take, let's say, how much? 11.5, not 11.5, 10.6. So instead of 4.6, take it 10.6, just above, the 10.5. It can be any number, a 10.6, 10.55 or something, whatever you want. And all other things are same because this X range is same for all slabs, right? Change. Now you will see that this loading is replicated. So I have changed the Y range. So you need to change the Y range of all the loads. Now again click here for one-way load, change this to 10.6. Means now this is also changed. Now again for SIDL.
सर मिनिमम रेंज चेंज करायची गरज नाही का वायची वायरिंग?
No, because see this slab is here. Na? So what I am doing by doing this, I am telling him where is the slab location. So this slab location is here till here, right? So there are 3 slabs here. So it will automatically detect that 3 slabs, 1, 2, and 3. So minimum I know that this is only 4.4. And maximum I am taking little above, which is 10.6. Getting within this range, whatever slabs are there, the load will be applied. Correct? Now you will see that uniform load is replicated actually here in this case. So Y range load doesn't gets replicated, but UDL gets replicated. So you know that uniformly distributed load minus 4 kilonewton per meter is actually copied. Now it depends on you whether you want these loads or not. Many times what happens, we apply the parapet load on the terrace and we apply the floor loads on the floor level. So generally floor loads, there are walls on all the beams. Generally, I'm not saying it is exactly always. So that means this is not right. So let me delete this. It is better to delete this. Now what I will do, I will click on the SIDL, then add, click on the member load and uniform force minus 4. Add, click on this and then I will select only these beams. So this is your parapet wall load on the terrace. Generally it is on the terrace. And then apply, assign to selected beams. Now if you feel that there is a wall load over here, generally it is there, but the height of the wall is 3 meters in this case. So what is the wall load of the 3 meter height? कितना आएगा वो? So it was actually how much? ये पहले वाला था वो. It was 1.2, no? Which is parapet, brick wall parapet, let's say. And let's say brick wall floor. So 0.15 into height is 3 meter in this case and 20. So it is 9 kilonewton. Now I will apply these wall loads on the lower floors. So first up, I'll define this. Click on the SIDL, add, then member load minus 9, then add, close. Click on this minus 9 and now select these beams. So if you have the walls over here also, then you can click this. That means all the beams are having 3 meter height wall load. It is as per your architectural drawing. If the walls are not there, then you don't apply that. And then assign to selected beams. Got this. Now all other things are same. Combinations are also same. Whatever we discussed last time. Like, yeah, this is missing. So it will be 10.6 for live load. So you may be understanding that if you want to prepare any multi-story building model, first define the only single floor, assign the properties, loads and everything, and then just copy it. If they are same, if they are not same, then you change wherever is the change. Okay. So there is a possibility that there are some additional beams on the second floor. So you just add that beams by using insert node and change the loads for that portion only. All other things are same. So generally in apartment schemes, we have odd and even floors same, means odd floors like 1, 3, 5, they are same. So I think you know in multi-story buildings, generally I'm saying. So let's say this is, for example, let's say we have a balcony. Let's say this is your first floor, this is your third floor, correct? And let's say this is your fifth floor, and this is your second floor. This is second, then fourth, sixth. This is your 1, 2, 3. Sorry, 1, 2, 3, 4. 1, 2, 3, 4, 5, and 6. So generally we have balconies on first floor and third floor, fifth floor to this side. And there is a possibility that for even floors like 2, 4, the balconies are here, let's say. So you can see that first floor and second floor are different. But first and third is same, fifth is also same, then second and fourth is same, and maybe sixth is same, or sixth may be terrace. It depends. That means you need to model first floor and second floor and then copy them above using translation repeat. So that way you can optimize the time of the modeling, right? So you need not to do whole model actually of the high-rise building. Just copy it. And only you need to change the wire range loads in that case. That's it. Is it clear?
Yes, sir.
Okay. Now, okay. So 1.5 dead load, 1.5 SIDL. This is a limit set combination, which is a strength criteria. So can anybody tell me where this combination is used? This combination. Yes.
Gravity loading.
Yeah, it is for gravity load first. Then we use this combination for design of members. Okay, design of members. Members may be beams, columns, slab, footing, whatever. Because our RCC design is based on limit state method. Okay, where IS 456 is the code, and we are using this and limit state. That's why we take the what we take in limit state. We give the load factors in limit state, and that load factor for gravity loading is 1.5. That's why we are putting 1.5 here, and we are using for design of members. Please understand. Now, if I ask you, let's say I want to check the deflection of this beam. Let's say I want to check what is the deflection of this beam. Okay, so let's run this first. Let's go into modeling mode only. Now, if I ask you, if I want to check the deflection of this beam, can I take this combination? For which load case or combination I should check the deflection of the members, like beams? Yes. Can I use this combination for checking the load deflection?
No, sir.
So what combination we take for deflection check?
Factor
Yes,
will be 1 itself.
Yeah, 1. So see, so there is a, you know that there is a limit state of collapse.
Yes, sir.
Which is a strength criteria, and strength criteria is for design of members. And there is second case, limit state of serviceability.
Serviceability.
It is given in IS 456. This is deflection criteria. Okay. So deflection criteria, that means we should take the load combinations, service load combinations, or I can say working load combinations, whatever you say. Working load combinations, or this is service load combination, whatever name you give here, doesn't matter. And the load factor is 1. So 1.0 dead load plus 1.0 SIDL plus 1.0 live load. That means I need to define one more combination for serviceability criteria or deflection criteria. So let's define that. So how to define the combinations? Click on the load case details here, add, then click on the define combinations. Now let me say here as 1.0 dead load plus 1.0 SIDL plus 1.0 live load. Now what is the load factor here? 1. So put here 1. Then see, click on the dead load, take to the right, SIDL take to the right, and live load take to the right. Don't take this, this is a combination. Please remember, we are giving the load factors to the load cases only, not to the combinations. Don't take this to the right, otherwise the load will be more, isn't it? This will also be added, so it will be wrong. So yes, then click on the add and then click close. So we have got this service load combinations. Now if you want to check the deflections of the beam, then you take the results of this. Now let's see how to see that. Click on the analyze, run analysis. See, generally what we do, first we click on the perform analysis. You need to do it only once. Don't do it multiple times. No, it is not required. In any model, you should click on the perform analysis once at the start of the modeling. Once you do that, then only you can run analyze directly. So if you do changes in the model, do the changes and just run analyze. Okay. Now I'm taking all these to the left side by clicking here, and I will take only these 2 load combinations to the right, because I'm interested in the results of these 2 load combinations only. Apply, OK. Click on the beam, click on the graphs, Let me hide this and see the bending moment. Now, whenever you write down the bending moments, let's say if I click over this, now here you can see in this tab 1.5 dead load, 1.5 SIDL. That means these results are for these combinations. Now there are all the load cases and combinations here. If you click on this triangle, so there is a dead load, SIDL, live load, then 1.5 combination, one combination like this. So whatever results, if you want, you can click. If I want to the results for this combination, click on this, then you will see this. Now you can see is 118 is the bending moment for this combination, which is service load combination. If you click on the 1.5 case, then it is a 27. 18 into 1.5 is roughly 27, right? So for designing, we will take this result. So if you all of you know that for designing, we use Excel programs, or you can do manual calculations also. So put these results for design of beams or columns. Okay, don't forget. Otherwise, if you don't check this, what is here, then there will be problem. So you can note down these results on the plan and then do the design. Now, if I ask you, I want to check the deflection of this beam. So let me hide this first. Then click on this here. But see, there are no deflection values over here. Even though you don't click, doesn't matter. Click on the beam, double click on the beam, double click. Then here you will see this is a window and there are so geometry, property, loading, shear bending, and deflection. Click on the deflection. Now here you can see selection type. There you select that service load combination. And what is the direction of deflection actually? How will it deflect? It will deflect like this. That means what is this direction? Y. So you need to click here to the Y, right? So click Y and then service load. Then what is the deflection here? Minus 1.219. And displacement is in mm, please remember. Okay. Displacement values are given in mm.
Yes, sir.
So this is the deflection which is coming at the center of this beam, minus 1.219. So you can check that deflection as per the IS code. Generally, it is L upon like 350 roughly. So if you know this is what is your span of this beam? 4,000. And what is 350 divided by 350? How much is this? हमारा इसका actually what is delta actual? Minus 1.2. Minus 1.2 because it is given downward, that's why. So 1.2 mm, let's say. And what is this value?
11.42.
11.4 mm, let's say. So that means this deflection value is less. That means it is okay. Correct? Actual deflection is less than permissible deflection. This is your permissible delta. So all of you know that in any design, there are only two criteria, strength and serviceability. That is the design, nothing but. Serviceability means deflection, let's say. So we design for strength and we check the deflections for service load combination. That's it. That is the design. So what is strength criteria? What is meant by design? Can anybody tell me? In short, what is design of any member? Or what we do in design? Basically, fundamentally what we do
So
in design? Yes?
to provide a specified size of members.
Yes, to provide specified size. Then what we check?
Strength.
Strength
So
and
what we check
deflection.
in strength? Yeah, strength means what we check?
Resistance to
How much load it can take.
No, see how much load, not what is the stress, actual stress, and what is the permissible stress. So actual stress should be less than permissible stress. That is design strength criteria. Okay. So stress may be actual stress in case of column generally. stress may be
Bending stress.
bending stress, and that too bending sigma b compression bending stress, then tensile bending stress sigma bt, or there may be shear stress tau, right?
Oh, see.
Tau c, yes. So all stresses, even the tau c actual should be less than tau c permissible. So permissible stresses we get in code. Sigma bc actual should be less than sigma bc permissible. Similarly, all. So all kind of stresses should be less than permissible stresses given in the IS code. That is design. And what is serviceability? What is serviceability? Delta actual
Is
less
less than
than
permission.
delta permissible. Permissible stresses are always deflections or stresses. They are always in the code, and actual stresses or deflections we calculate in the analysis. Okay. But in analysis, we don't get directly stress, we get the forces.
Bending
So what
moments.
we get in the analysis, forces. So forces may be bending moments, that is M,
Shear force.
shear force, that is V, right? And then M upon Z is bending stress, and V upon A is shear stress, right? Tau and sigma B. And axial stress is what we get in columns, axial forces, Fx. So which is, we can say Fx is the axial force, and divided by area is nothing but sigma A axial force, axial stress, right? AC, let's say axial compression less than sigma AC permissible. So this is the only design actually, whatever material you use, steel, RCC, timber, aluminum, whatever materials are available in the market for construction, this is the only philosophy of design. So nothing is different. Structural engineering is really easy field, provided you understand the basics and don't forget it. Always relate your complex problems with the simplified way of the design and all this plan. This is the case in any, only the numbers are different. Permissible stresses, if you are taking the steel structure, like rolled sections, channels and beams, then these permissible values are different. So that means these permissible values are different as per the material, steel, concrete, timber, or whatever. And these stresses are actually same because analysis is generally same. It doesn't change. Okay. So this is the thing. Now let's learn some more parameters. Yes.
So स्टैड प्रो सर कितने स्टोरी बिल्डिंग तक यूजफुल है सर डिजाइन के लिए?
100.
जैसे 100
100 भी कर सकते हैं. You can do 100 also.
एक्चुअल में सर मैंने कहीं देखा था, उसमें बोल रहे थे कि फिर सॉफ्टवेयर मतलब ई टैब्स के कंपैरिजन में स्लो हो जाता है जैसे जैसे नंबर ऑफ
नहीं,
स्टोरी
स्लो है.
बढ़ते हैं,
इट इज
इसलिए
स्लो,
ये
वेरी
डाउट
स्लो,
है.
वेरी स्लो. हाँ, यस यस यस. स्पीड के बारे में बताया गया तो यस, इट इज वेरी स्लो. If you do 100 story here, then it will take hours to run. If you click run analysis, then it will take hours to run. Hours means, I don't know, 4 hours, 5 hours, whatever. You need very high processor actually for Staad Pro. Processor, RAM, everything you should have high configuration. But that is not the case with ETABs comparatively. Yes, ETAB also takes time. Because ETAB is, we are modeling the slabs there. Yeah, good question you asked. So in ETAB also, it is not very fast. Huh? If you model the slab in ETAB as a shell element, then it will also take too much of time. ETAB also. Huh? If you model the slab as a membrane, then it will take little less time. Okay. So that means for high-rise buildings, computer configuration is required very high. Okay.
Yes sir.
There is no other way. As we are dealing generally practical purpose, as a beginner for all of you, 10 story, 15 story, 20 story is fine for the softwares. But if you go more than 30 stories, then your computer configuration is also important in that case.
Yes, sir.
Yeah. Now let's learn. Now, if I ask you, so instead of, let's say, instead of this, I'm just telling you the modeling part only. Now you know how to apply the loads. What is one-way load, two-way load? See, software is not telling you is it one-way or two-way. You are deciding that. Let's say in our problem, we have one more beam here. Okay. Now, is it a secondary beam or primary beam?
Secondary beam. Secondary.
It is secondary beam because this beam is resting on this beam, and this beam is primary beam. B7 is primary beam, and this is secondary beam. Now, I think I told you, all of you, whenever the beams are resting on the beams, then consider this as a simply supported.
Simply
Okay.
supported.
If the beams are resting on the columns, let it be fixed connection. I think last time somebody asked me.
Yes, sir.
So this should be the simply supported beams, and when there is a simply supported beam, that means the bending moment is like this, which is WL square by 8. So moment is 0 at the ends, right? Now software doesn't understand whether you are saying it simply supported or fixed. It is taking by default fixed condition in any softwares. If you want to forcefully tell him that make it simply supported, then there is a command for this. I will tell you. Now let's model this beam first. काम करेंगे. Let's take. I want beam here like this. Now tell me how to add the beam here. How to add beam? Select these two beams. Insert node at the midpoint. And then add beam. Then click here. And give some size to that. Let's say same size. Assign to selected beams. Now load will also change, isn't it?
अगं तुम्ही आपले हे कट करायचं इथले एका पिनची ऑरेंज कलरची ही उचली
काय पाहिजे काय झालंय
काय नाही
Now
वापर ना
here the loads will change. You can change the loads. I'm not going in detail regarding the loads. Okay. So let me take any load here. You know load path and what load should be there. Once you add this beam, the load pattern will change. Please remember, this will not be one way, it will be two-way load. Okay. I'm just arbitrarily taking some load on this. Now run this. See, now we are trying to learn the commands actually from Staad Pro. Then click on the post processing, click here and then click here. And then see the bending moments here. Now if I click over here, if you click here, can you see this bending moment diagram is changed? Now, do you expect this bending moment diagram for this beam? Yes. Do you think this is your expectations?
No, sir.
So it should be something
Parabolic.
like parabolic, and
Downward depression.
it should be like this, right? This is your expectation.
Yes, sir.
And it should have a zero moment at the ends and maximum here, correct?
Yes, sir.
But it is giving moment at the ends also. That means this is not simply supported beam. So by default, any software takes fixed condition at the ends. So I want to make it simply supported. So there is a command. Now let's go into the modeling again. Now tell me why I'm expecting this to be simply supported and not fixed. क्यों नहीं करना मुझे fix ये? मुझे simply supported ही क्यों करना है?
Primary beam में torsion आ सकते हैं.
Yes, primary beam में torsion आ सकते हैं उसमें. So बढ़ेगा मतलब it will increase. There is a torsion always in the beams. थोड़ा थोड़ा तो रहता ही उसमें, but it will be. Now how to see the torsion? Now we last time have seen MZ, Fy. MZ is bending moment, Fy is shear force,
Shear
and
force.
Fx is axial force. Now how to see the torsional values? So क्या करेंगे? I will do one thing. I will click here. If you want to see the torsion value, I will show the torsion values in this window. Let's see. Click here, then click on the reserve. What? View. Click on the view diagrams. Now here the forces are given. So here bending ZZ is here actually. Click on the torsion here, then click OK. Now if you click over here, then you will see that 1.67 is the torsion in this beam. Then in this beam, it is almost negligible, 0.33. That means 1.67. This torsion is coming due to this beam, right? Because it is fixed. And generally, we don't want any major torsion values in the beams. Okay, so I want to ignore that torsion. That's why I want to make it simply supported. Getting? Now let me hide this again. Now how to do that? Click on the modeling, then click on the general and click on the spec here. You click on the spec, then click on the beam here in this window. Now there are release command, release, start, end. So click on the release, then click on the start and release the moments. Start means start node, start of the beam. Click MX, MY, MZ. I want to release all the moments, MY, MX and torsion, everything. Click add. Okay, now if I click over here and then click assign to selected beams, you can see this blue dot. That means this side we have released the moments. That means there will not be any moment after the analysis here. Now I want the right side also to be simply supported. So I will release the end node of this beam. So you need to create end release also. So I have first defined the start release. Now define the end release. Click on the beam, click on the end and click on MX, MY, MZ and then click add. And then select this beam and assign to selected beams. Now you'll see the blue dot over here. So both the ends are now released for the moments. And then you can analyze again. Click on the post processing. Beam graphs. Now here. Now it is as per our expectation. Correct. Zero value is here. And minus 0.738. It depends on the loads. So this way you should release the beam moments at the ends for if you are expecting the simply supported beam. Okay. Is it clear to all of you? The command, release command, start and end. Yes or no?
Yes, sir.
Now there is a trick. Let's go. Now let's assume that we are having one more beam over here, here like this. So right click here, insert node at the midpoint, and then add one more beam here. Now, is it secondary or primary beam? This beam is primary or secondary? Secondary only, because it is resting on the beams. Now let's give some properties to that. Assign to selected. If you don't give any properties to the member, then Staad will not analyze the model. Okay, so there has to be all properties given to the model. Now let me give some arbitrary load for the time being. I'm not going in detail of that. कुछ तो लेंगे मुझे 2 है. Now tell me, will it be simply supported or not?
It's a continuous.
It's a continuous beam.
Fixed at one middle.
So it is a continuous beam, but this end is simply supported. It should be simply supported. Otherwise, this will transfer the torsion here in this beam. I don't want torsion in this beam. So what I will do, I will release this part only. Okay. Will I release here?
No, sir.
It is a continuous, so I will not release. Will I release over here? Yes.
Yes.
Because it is resting on the end beam. So I would say if it is resting on the end beams, then release it. So there will not be release here at the continuous support. We will release only at the ends. So that means now here what we have done, we have also given the release over here. So we will delete that release. So click on the general spec. Now let me delete this first. Let me delete everything. Let's say. Now there is no release given to this. Now again click on the beam, start, then we will release the start, then create the end also, end. So I'm defining start and end releases. Now start release will be given to which beam? Here or here? Now what is the start of this beam? How will you understand what is the start? What is mean by start?
0, 0.
Oh no, for this beam, what is the start? Is it left side or right side?
Left,
See,
right.
start is defined how you have drawn the beam. For example, see, I know that I have drawn the beam from this point in this direction. Yes or no? I have
Yes, sir.
selected this node first and then I have selected this node. That means this was the direction of drawing. So first node is the start node. Okay. And the second node is the end node for this beam. Correct. So this is your start. So I want to give the release to the start or end?
Start.
Start. Because I want release over here. Na?
Yes, sir.
So click on the start and click on this beam and then assign to selected. So you see the blue dot over here. So now for this beam, shall I give the start release or end release?
End release.
So click on the end, then assign to select. Now if I give the release to the start also, what will happen here? Let's say I have given the release over here also and here also. What will happen? Then these two beams will be simply to supported beam and your bending moment diagram will be like this. Correct? So this will have a 0 moment. This will have a 0 moment. This will have 0 moments. Correct? If you give the releases to both the ends. Now in our case, we are only giving the release over here and here. That means the moment at this point will be 0. And then here it will be negative moment and again it will be 0. Right?
Yes, sir.
It will have a negative moment here. Continuous moment. Negative. hogging or negative, whatever you say. Generally, we expect the continuity in the beams if there is availability, because the moment. So tell me why we are not doing it simply supported. Why we want continuous? क्यों चाहिए बताओ? Let's
Economical design, sir.
learn.
Economical
Yeah,
design.
economical, because see
To
what
use
happens if you
compressed
take,
steel.
correct, if you take simply supported, then this will be WL square by 8. This will be also WL square by 8.
Right.
This is maximum moment comes in the beams, any beams actually. But if you take this as a continuous beam, then this will be less than WL square by 8. This will be also
sir.
less than WL square by 8. So you will have a economical design. Economical design and optimum distribution of the forces within the members. So that is important. That's why we use the continuity.
Less compressed steel also.
Yes. So now let's run this. Now still there are some results, but it is very, see, sometimes due to the, what can we say, depending on the geometrical dimensions, there is a possibility that you get the moment at the base, but because this load is very less, if the load is more, then there is a possibility of negative moment. Yes. Okay. So this way you can handle the release command, start and end release. So you must be understanding that, see, software is only a calculator actually. Please keep in mind. And modeling is an art. Art means you are deciding what kind of forces you want in the structure, and then you force the software to do accordingly. So we are deciding the modeling part. So modeling is actually technique and art which you can use your engineering knowledge, basic concept and behavior of the structure, and tell him to give the forces accordingly. So that is the modeling part. So modeling is quite vast field actually. It is not the software. Modeling is not something related with the software. Modeling is something related with the engineering. Please keep in mind. See, many times people feel that modeling is something related with the software. No, it is not that. See, we have also done in engineering college, we have analyzed such kind of structures. Then we have given the forces like this, and then we analyzed manually. This is also a modeling. Please keep in mind. So modeling can be done manually also. So not necessary that it can be done only in softwares. It can be done in done manually. See, whenever I do modeling, I decide these supports. So I decide whether it should be fixed or hinge or what. Then I decide whether this joint should be fixed or rigid. I decide what should be this load. I decide what should be the spacing of the columns. I decide what should be the span of the beam. I decide the size of the column. So I am deciding everything. I am creating the geometry of the structure. Sometimes I feel that I want bracing here. Sometimes I feel that I want shear wall here. So see, everything is decided by an engineer, and accordingly he, as per his expectation and the behavior of the structures, he will suggest this. So this is called as the modeling. If you feel that modeling is something related with the software, then it is not correct.
सर कंटिन्यूस बीम में क्रॉस सेक्शन एक ही चाहिए सर, क्या वेरिंग चलेगा दो बीम का?
चलेगा. See, varying किया तो what will happen? There will be torsion here in this beam. Good question. Let's see this. See, many times these are the concepts actually which needs to be learnt really something. Let's say you have this beam. Now this is your continuous beam. This column beam is resting on this column. This is resting on this column and beam. Now you see that this beam is having lesser depth than this. Now you are asking whether it should be same size.
Yes.
What, by looking at this picture, what do you think? What will happen to this beam? क्या होगा इसका?
Torsion, I guess.
इसमें टॉर्शन आएगा क्योंकि अनबैलेंस मोमेंट हो जाएगी ना
Yes, yes, sir, yes.
ड्यू टू दिस साइज, ये इसेंट्रिसिटी की वजह से. There is a eccentricity here, you can see. Due to that there will be unbalanced moment. So समझो ये bending moment हमारा ऐसे diagram है ना. So for this beam the bending moment diagram is very high. Then as this depth is less, then bending moment will be less here, like this. Can you see this? Let me give the number to this. Let's say this bending moment is 50, and for this beam let's say it is a 70. Correct, for this beam. Why this 70? Because it is having more depth, that means stiffness is more, that means it can attract more moment. Why this is lesser than this? Because this depth is less, so stiffness is less, so it will attract less moment. That means there is a difference of 20. So this difference will go into this beam as a torsion. So that's why I generally recommend to have the same depth. Even though this span is less, please understand this. Even though span is less, you will say that why it is required unnecessarily. I suggest to avoid this torsion, you can keep the same sizes. That's mean in this case, also it is better to have the same sizes of the beams. Got it?
Yes, sir, thank you.
Now, okay, let's learn some more commands regarding the Staad Pro. So, yeah, now whether it is a start or end, we discussed. How can you understand how you drawn the beams? So there is a possibility that some person has drawn the beam from right to left like this by mistake due to error or what. So that means you don't know what is the start node of the beam, what is the end node of the beam. So how to see that, I will tell you. If you take this cursor and just take this cursor near to the beam, you will see that green, red and blue colors, right? Take this cursor near to this beam, green, red and blue. So green is always start. Getting? And blue is always end. Now if I take the cursor here and see, green is behind at the back side and blue is here at the front side. You know that from here to here I have drawn this beam. That's why it is showing like that. Here also. Now how I have drawn the columns?
Bottom to top.
Bottom to top. And if you just take this cursor, you will see that green is below. That means start. Correct? So this way you can understand whether it is a start node or end node. Now, if you want to see the start and end nodes of all the members at one time, instead of taking this cursor to each and every member, how can you do? Let me tell you. Right click in the window, click on the labels. Here you can see beam ends. Click on the beam ends and click apply. Okay. You can see green and blue colors. Now here it is very clear which are the start nodes, which are the end nodes. Generally start and end nodes we require for releases. Got it? If you don't want to see
Yes,
this,
sir.
then right click, labels, Then again click on the beam ends, apply. Now it is hidden. Now this is your property, and many times if you feel that you want to see the nodes actually at the junctions to understand, many times we require to understand that. If you want to see the nodes clearly on the view, then right click, labels, click on the node points. Okay, you can see here, apply. Now here you can see the nodes, dots. Previously they were not there, right? So many times this is very useful to keep this view on. All the nodes should be visible in any view. Whatever you click, anywhere you click, all the nodes are visible. And if I don't want, then click on the labels and click on the node points. Uncheck this. Now in this view there is no node. All other views there is no node visible. Again right click, labels, node points. Now there is one more way, labels I will tell you. Now if you want to see which is the number of this node, if I ask you what is the number of this node number, you can take this cursor near to this. This is a 13 number, 14, 15. Now if you want to see the node numbers for whole structure, right click, labels, click on the node numbers, apply. Now here you can see 13, 14, 15. So many times we may need to see these node numbers in modeling, then you can keep this on. And if you don't want, right click, labels, node numbers. You can see the beam numbers also, beam and column numbers. Take this near to this, beam 27, right? Beam 29, beam 9, beam 1. Right click, labels, beam numbers, apply. Now this 27 is for this beam. Okay, 38 is for this beam. So you can view the beam numbers, node numbers from labels. These beam and column numbers are nothing to do with your practical beam numbers and column numbers. Please keep in mind, we don't take the beam numbers from the Staad Pro. Okay. So they are only required for the analysis and we are not bothered. Now you will find here one issue. Tell me, what is the span of this beam? Is it 2 meters or 4 meters? This beam? This beam is resting
4
on this
meters.
beam. It is a 4 meters. I'll tell you. From here to here, it is the span,
4
right?
meters.
But if you click here, then you will say that the beams got split into parts. Okay.
Yes.
As far as behavior is concerned, there is no problem in this. You will get the bending moment diagrams as per the primary beam only, no problem. So here you can see. See, it is assuming that it is a one beam only. So there is no problem, even though it is split in two parts. But there is a issue with the Staad Pro software that whenever you add any beam whenever you support any secondary beam on the primary beam gets split into parts. There is no problem regarding the behavior, but you need to click each and every part. For example, if you click here, you will see that 30.5 is this end moment and 34.5 is this center moment. Now, if you want to see the results on the right side, click on the right side beam and see these results. Getting? You don't get the results in one shot. Click on each part and see the results in parts. This is not the case with the ETAP software. So that is one of the major, we can say, advantage in ETAPs compared with the Staad. See, those who have done with the ETAPs, they will understand. Those have not yet completed high-rise building, you will understand at that time. So आप कुछ लोग रहेंगे जो स्टैड पहले सीख रहे हैं, बाद में ETAP सीखेंगे. कुछ लोग है ऐसे कि ETAP ऑलरेडी सीखा है, स्टैड सीख रहे हैं. So this is also one of the major advantage I generally feel in ETAPs. Okay. Now we will see regarding the results today. Coordinate axis system, which is very important in any softwares. Go into the beams, graphs. अब एक काम करता हूँ मैं. We have selected only. I'm just taking the plain beam part. Okay. Now you may be surprised why it is saying MZ. Why not MX? Why not MY? Why it is MZ? So how to see the results of the StatPro software? So there is it depends on the local axis coordinate system. Okay. Local coordinate system. So in any software, the results are, I'll go there. Any software, the results are with respect to the local coordinate system. So there are two coordinate systems. One is local and second is global. Global means you can see this is the global axis. Generally, we see the results of the support reactions with respect to the global axis. And we see the bending moment, shear forces and axial forces with respect to the local axis. Okay. So local axis means what? It is nothing to do with the global axis first. Understand this. Now let's say we are having one beam. ETAP में जिनका हुआ है उनको आसान जाएगा ये समझने के लिए. Okay. Let's say this is a beam. And whenever I draw beam, let's say this is my start node and I have drawn this in this direction. And this is my end node. So this is my start node, this is my end node. And this was the direction of my drawing the beam. You know, if I want to draw a beam, I select this node first, then I go to the right side in this direction and I click on this node. Then this beam gets generated in the line form. Generally, the beams are generated in line form. We call it as a line element. Yes. समझो ये beam है हमारा. So it is a line, right? So this is your start node. You know, if you click here, this is green, so it is start and this is the end. So what was the direction of my beam? This one. So this is your start, this is your end. In the similar fashion, I'm just drawing here. So whenever you draw any beam, the direction of this drawing, or I can say this is the axis of the member which is passing through this member. So this axis is X. Local axis, I'm talking local axis. Whenever the axis is drawn on the members, it is a local axis. Then you know that this is your depth of the beam and this is your width of the beam. So the axis which is cutting the depth is Z and the axis which is cutting the width is Y. Okay, समझ में आ रहा है सभी को?
Yes, sir.
Now let's say ये मेरा ऐसे बीम है, यही बीम है समझो, but I am this is your, and there is a load like this. All of you know that there is a load like this. This and this beams are same. Due to this beam, what will happen? This will bend. Correct? Now, in which view you can see the deflected shapes? This is your view. If you look from this side, what is this direction? View direction is?
Z.
So view direction is Z. So if you look in the view Z direction, then you see this bending moment. Yes or no? ऐसे रहेगा ना
Yes,
bending.
sir.
That means the axis perpendicular to the plane of the bending is the moment. So ये moment रहेगा मेरा mz. Okay. About this z axis. That's why this is your mz. Getting all of you? If the beam bends in plan, समझो ऐसे plan में bend हो रहा है समझो ऊपर से, I can see in this view. What is this direction? Y. And where you see the bending, if you look from the y direction, then you see this bending in plan. That's why it is called as the my. So the bending in plan is my, bending in front elevation is mz. And if it is the moment about x-axis, what is this? क्या है ये? mx is what? About x-axis, if there is a moment, what we call it as a
Torsion.
torsion. Have you got what is mz, my, mx? समझ में आया कि सभी को?
Yes, sir.
Now, due to this load, there will be reaction like this, there will be reaction like this, and there will be shear force. So this reaction is generally we call it as a shear force. Yes or no?
Yes.
And if you draw the shear force diagram, then it will look like this. So that means it is your V. Correct?
Yes, sir.
But what is this vertical direction? This direction with respect to this, ये कौन सा direction है?
Y.
So this will be your Vy, or in Staad language, ये क्या है? Fy. Okay. So they are not saying V, they are saying Fy. But Y is the important thing due to this axis direction. So all the shear forces will be in this direction Fy. If you have the shear force in plan, sometimes there are members which may create bending in plan due to such kind of loadings or lateral load. So there will be shear force in this direction. ऐसे कुछ तो रहेगा. In this direction. So what is this direction? ये वाला plan में. If you look from the,
Yeah.
so it will be Fz. So Fz will be the shear force in that direction if there is a bending in plan. Okay. In the front view, Fy is the shear force. Mz will be the moment which we are interested in the design. Now what is the Fx then? Fx क्या है? Axial force. Yes.
Yes. Yes.
So there are three forces: Fx, Fy, Fz. So Fy is a shear force. In which plane? Plane कौन सा ये? मतलब ये और ये ना? XY plane बोल सकते हैं या you can see the view. So Fy and Fz are shear forces. Fx is axial force. Mx, My, Mz. What is Mx? What is My? Bending moment. Bending moment about y-axis. About. And what is Mz? Bending moment about z-axis. Generally, in beams, we are interested in this Mz and this Fy value. For column, what we are interested in? Column में क्या क्या रहेगा?
Axial force.
So column में
Bending.
तो moment भी रहेंगे, that will be biaxial moment. So in columns, we are interested in Fz also, Fy also, axial force also, My and Mz also. Generally, we don't expect torsion in beams or columns generally. So these My, Mz will be in column, then axial force will be in column, and shear force also will be in column, both shear forces. In beams, we are only having Fy and Mz. There will not be axial force in beams in general. There will not be torsion in beams, and there will not be My in beams. If there are gravity loads or earthquake loads, My is not there. So Mz and Fy. That's why you'll see that by default, the Staad has given these windows only, Mz, Fy, and Fx. Okay. Mostly we are interested in these results. Now, if, with respect to column, if you take the column, same is the case. For example, whenever you draw the column, how you are drawing the columns? What is the node? Generally, we start from the bottom node. If this is the bottom node, which is start node, this is your end node. Then, what is the direction? This is your direction, yes, of the drawing. Let's say this is your column here. This is your start node, this is your end node, and you're drawing from bottom to top. So that means this axis is always x-axis, correct? Then what is this axis? ये कौन सा axis है? Cutting the depth and cutting the width. Getting? So the moment about z-axis will be mz, moment about y-axis will be my, and moment about x will be torsion, which is mx. Then fx. So fx will be axial force. Then shear directions are which directions actually? Let me draw here. If I say this is what f, x or y? Fy. And what is this shear value? F z. Shear forces are with respect to the direction of the axis only. Along the z, fz. Along the y, fy. Along the x, fx. So axial, these forces are along the axis and moments are about the axis. Mz means about this. Okay. Generally, it should be drawn as per the right hand thumb rule. Right hand में कैसे रहेगा ये अलग है. Do you know right hand thumb rule? पता है क्या सभी को? If you use the right hand, then thumb shows the direction of the axis and curly finger shows the moment direction. So ये कैसे रहेगा? This will be the direction of the moment mz and इसमें कैसे रहेगा? Clear to all of you? So that means you can say that beam or column, the system is same. Along the axis, x-axis, cutting the depth, z-axis, cutting the width, y-axis, and the moments about that axis is the axis of bending. So z is mz, about z is mz, about y is my. And along the axis, the forces are along y, shear force Fy, along z, shear force Fz, and along x, axial force Fx. Got all of you?
Yes, sir.
Now you can go in the model and then you will understand that. Now that's why this is mz. Abhi samajh rahe? Don't look at this. Whenever you see the results of the members, don't look at the global axis. It is nothing to do with this. Okay. So click here and then this is mz. फिर बताओ क्या है? Shear force क्या है इसका? Tell me shear force for this beam. Fx, Fy or Fz?
Fy.
It will be Fy. It will be Fy. ये वाला Fy. Because ये मेरा x है. अभी Fy, this is my beam. Beam कैसे रहेगा मेरा? ऐसे रहेगा ना?
Yes, sir.
And this axis is y, cutting the width. This is your z. And this is your x. So this is fx, fy, fz. Got it? Similarly, moments. So relate this. Even for this, even though the direction of the beam is here, the philosophy is same. That's why you see the bending moments like this. So this is your x now in this case. Now what will happen to the column? This is fx, that is axial force. That's why it is given fx here. Okay. I hope all of you got the coordinate system.
Yes, sir.
Now let's learn some more commands. Let me see the whole structure. Now there is a view management here. You can now see many times when the model is of very large size, then controlling the model it becomes very difficult because see there is this column, these beams, and there is a very clumsy structure we can say. In that case, what you can do, you can save different views as per your choice. Let's say I want to save the view of the plane beam. What can I do? Let's go into the front elevation, select the only plane beams like this, and then say view selected objects only. Now this is your plane beam layout only. Now you can save this view. Go into the view management, save view. Now name this as plinth beam. Plinth beam level. Okay. Click OK. Then again go to the view and show whole structure. Now let's say I want to see only plinth beam level. Go to the views, go to the view management and go to the open view and click on plinth beam level. Okay. Now only plinth beam layout is visible. You can create more views. Let's say I want to create a view for first floor. View, first of all, view selected objects. Now this is your view. Go to the view, view management, save view. Now let's say it is a first floor. Click OK. Now go to the view whole structure. Now you can control the views as you wish. Let's say view, open view. Let's say I want first floor. Okay. Let's say I want only plinth layout. Go to the plinth. See, this is very useful command because many times, let's say I want to only put the loads on the plinth beams. So instead of putting the loads in this view, because many times if I click on this beam, then even column gets selected. So there is a problem in modeling or controlling the model, let's say. So it is better to just open the, let's say, plinth beam view and then go to the loads and you can apply the loads as you wish. Okay. It is very easy to control and apply the loads, give the sizes in this fashion to select the members also, because there is nobody other members like columns and other beams which are creating problem to me. Okay. So this way you can create the views. Then next part is if you want to add the beams, we know that we want to create the nodes here and then I will add beam, one more beam. Let's say I want to draw a beam at the midpoint of this, like this. So if you go here, add beams, geometry, add beams and add between midpoints, add beam between midpoints. And if I click here to here, directly we can generate the beams. So no need to insert the nodes and then add beam. You can directly jump, but only it is applicable for midpoint to midpoint, not other. If you want at 1 meter distance, then our previous method is good. There are different ways of drawing the beams and so on. Even add beam by perpendicular intersection, that is also there. For example, let's say I have one node over here. I want to draw a beam like this. I'm sure that this beam will be perpendicular to this beam. So instead of adding one more beam over here and then adding beam, I will click on the geometry, add beam by perpendicular intersection. Then select this and just click here. Directly you can draw the beams. If you want to see the 3D view, last time we have seen you can see 3D by structure diagrams, full sections, apply and OK. So this is your 3D view. Then again, structure diagrams, none. You can see the rendered view also like this. Right click and see 3D rendering. This way also you can see the view, but generally it is of no use much because you cannot control this. You cannot select any member from this. Only you can view. So most of the times I generally feel this is a better for me. because I can select the members in 3D also, like this. So I can even give the loads if I want. So this is in general actually the major important aspects of the Staad Pro. Still there will be session tomorrow also, additional tomorrow. But I hope you are practicing on this. Please do this model, whatever commands I told you. Any doubts?
So when we give floor loading, we can use the X range value also if we have many slabs in the same level.
Yeah, but you need to give different X ranges, right? You can have the Y range same, but X range will be different. Z range will be different, right? So see,
So
for this, this is your slab. So you need to define X range for this. Let's say this is 0, this is 1, and this is 4, Z range. Then for this slab, again, this will be 1, 2, 4, then here 1 to 4. And for this, it will be 4 to 5. So there are 3 slabs. So 3 ranges for X you need to give. And that is the tedious part I feel in Staad Pro actually. That's why in buildings, ETAB is more popular. समझ में आ रहा है? Are you getting? Why
yes.
we are in training taking high-rise building by ETABs, not by Staad. That is the reason, because in buildings, putting these ranges, Y range, X range is really tedious job. Because in practice, we don't have such kind of simple problems. We are having a lot of balconies, staircases, then means one-way slab, two-way slabs, different rooms, living room, and so the plan is generally complex, and putting all the X range, Y range is really difficult task in Staad Pro for complex building shapes. But in ETABS, just draw the slab and put the load. That's it. It will take care of the distribution of loads, one way, two, and everything. But as a matter of learning, you should know how to do it. But as a matter of which software you want to use for buildings or other structures, it will be your choice as per your convenience.
हॅलो सर.
Hello.
ज्या ज्या वेळेला आपण बीम ऍड करतो किंवा काय करतो त्या वेळेला ते स्लॅबचं सगळं स्लॅबला लोडिंग वगैरे बदलत जायला लागतं.
Yes. It will change, definitely, yes. Because the aspect ratio will change. The span will change.
आणखीन तुम्ही म्हणला की फोर्सफुली मी 2 वे जर असेल तर 1 वे करू शकतो, मग ते होतंय त्या केसमध्ये?
हा, होऊ शकतं. आता झालं नाही ते. अदरवाइज यू नीड टू कॅल्क्युलेट द लोड अँड अप्लाय ऑन दिस. ऍक्च्युली ते व्हायला पाहिजे. आय डोंट नो आता मगाशी झालं नाही ते. पण नाही झालं तर यू अप्लाय युनिफॉर्म लोड्स.
ओके.
फायनली दॅट्स वाय वी आर लर्निंग बेसिक्स. बेसिक्स शिकण्याचं कारणच ते की मग आपल्याला समजा काही कमांडचं मिस झालं किंवा होतच नाहीये, देन वी कॅनॉट स्टॉप. Uniform load we can calculate and directly apply on the beams. So do that, right? So don't stop, because not necessary that software will give you the solutions of all the problems. Sometimes if it is not giving that, then you do it by classical way or basic concept way.
सर काही केसमध्ये कुठला तर मेंबर एखादा फेल दाखवला की ते त्याचं साईज वगैरे बदला लागते, त्यावेळेला सुद्धा लोडिंग वगैरे परत द्यायला लागतं का?
Loading with self-weight will change only, na, size change झाल्यावर. And self-weight you have already given. So if you change the size, let's say this property is there, instead of 450, I came to know that for design I require 750 by 230 beams, right? So what I will do, I will just double click this and I will change the size of this beam, and then that self-weight is automatically applied here. So it will automatically take the self-weight. So the increased load will come into all these combinations and everywhere. Correct? Generally, I recommend whatever sizes you are taking in the model, they should be in the design and in the drawings. And if you feel that at design phase, let's say I have assumed this beam as a 450 in analysis, and I have designed it by Excel or manual calculations, and I found that this beam depth I require 750. So what I will do, I will again make this beam as a 750, and then I will run analyze, and then we'll check the results. And for that bending moments, I will design and for 750 size. So that is the iterative process. So don't keep the model sizes different and drawing sizes different. Otherwise, the bending moment distribution will be different. It is always expected that the moment, sizes of the model, sizes of the design and drawings, they should be same, and all on site also definitely.
Sir, in detailing what we need to do when we give the release and without release.
Yeah, I think it is discussed in the basic session, but I will tell you again. Only L, the difference that you have to provide L in fixed condition and don't provide a L. Let's say this is your let's say this is your simply supported beam. Hinge, generally we call it as a hinge. You get the bending moment like this, 0 at the ends, and let's say M1, and let's say this is your fixed beam condition, load, then you will get the bending moments. Let me say MSMH. Okay. So I will design the steel for this moment, and I will put this at the bottom. Now, as there are 0 moments, so practically there should not be any steel over here because this is a compression zone, right? But for holding the stirrups, we generally provide the these bars, anchor bars we call it as. So they should be having less diameter like 8 mm or 10 mm. And I will only just put this like this. I know that this steel is still available over here. It will take a certain moment, but we can ignore that. It is very less moment carrying capacity at this point. Now here there is a hugging moment MH. That means I need to transfer this moment in the support, either it is beam, column, whatever. So generally we transfer it in columns. As I told you, we generally don't design beams, fixed beams on resting on the beams. So let me draw this as a column. तो फिर से confusion होगा. So let's say this is your but the span is same, load is same, let's say. In this case, for this MS sagging moment, I will provide this steel. Now here I generally we give the L for this. यहाँ L देते हैं. That means I will give L over here, development. Now, as there is a hogging moment here, I will provide L over here, development length. This is taking care of this moment. So whatever moment is developed in the beam, it will transfer in the column. Okay. And there will be nominal bar over here to hold the stirrups. Are you getting the detailing now? So there is no L in this case, and there is L in this case, development length. And you will design the steel. So this is anchor bar actually. I call it as anchor bar. That means no design. Nominal bar we are just taking. This green bar is designed for MH moment. This green bar is designed for MH moment. So AST we will calculate for this as per design calculations. This gray color bar is anchor bar, nominal bar to hold the stirrups. This blue color bar is designed for MS, sagging moment. This blue is also designed for M1 here. Got this now?
Yes, sir. Any doubts? So, okay. So shall we conclude today's session?
Yes, sir.
Okay, so thank you to all.
Okay, good night.
Thank you and good night.
Thank you, sir.
Good
Thank
night.
you, sir. Good night.
Good night, sir.
Good night.